Good morning. In this video, we are going to solve the first problem in area moment of inertia. Now let us go to the problem. Determine the moment of inertia of the following angle section with respect to centroidal axis and base axis. Now this is the given angle section where height is equal to 100 meter, width is equal to 50 meter and thickness is equal to 10 meter. Here all dimensions are in meter. Now this is the centroid, this is centroidal x axis, this is centroidal y axis, this is the origin O, this is base x axis, this is base y axis. We have to find the area amount of inertia with respect to all the four axes. Now the first step is you have to divide this angle section into irregular shapes. It is important because we know the formulas of regular sections like area, like square, rectangle, triangle, circle, etc., etc. But for a composite section, it is not possible to find the area moment of inertia directly. So we have to divide the composite section into irregular shapes. Now I am going to divide this angle section by 2. This is the first section and the dimension is here it is 100. I have to subtract this 10, so it is 90 and this width is equal to 10. For the second section, the width is equal to 50 meter and the height is equal to 10 meter. So this is what here I have done, the first section plus the second section, which will be equal to the final shape. Now let us take the first rectangle and draw a separate diagram for it. When you draw the diagram, make sure that these axes are positioned correctly according to the original composite sections. Then you have to find the values for 5 variables. The first 3 variables are similar to the centroid. Okay, next 2 variable is specific to area mode of inertia. The first one is x1, which is the distance between y axis and the centroid. This is the value, this is the x1 here, which is nothing but half of this distance, 10 by 2. So here it is 10 by 2, which is equal to 5 meter. The next one is y1, which is the distance between g1 and this x axis. So first you have to add this distance, which is nothing but this distance, here it is 10, then half of this one. So here it is 10 plus 90 by 2, 55 meter. Then the area of this rectangle, which is nothing but 10 into 90, 900 meter square. Then the next two variables are specific to area moment of inertia. Now the fourth variable is Ig1x, where I represents area moment of inertia and G1 is nothing but this centroid and the x is nothing but the axis passing through this centroid, this axis, x axis. Okay, so I have to find the moment of inertia with respect to this axis. Okay, now substitute all the values, then you get the answer something like this. The next fifth variable is Ig1y, which is nothing but the area moment of inertia with respect to the axis passing through this centroid. So this is the y axis which is passing through this centroid. Okay, so I have to find the area moment of inertia with respect to this axis. Now the corresponding formula is dB cube by 12. Substitute the values, finally get the answer as 7500 meter to the power 4. Similarly, you have to find the values for 5 variables for the second rectangle also, and this is the separate diagram for it. Here g2, x2, y2, and the distance is 50. Here it is 10. Now x2 equal to half of this one, 50 by 2, 25 meter. Then y2 is half of this one, 10 by 2, 5 meter. Then area is multiplication of these two, 50 into 100, 500 meter square. Now this one, Ig2x, moment of inertia with respect to this axis passing through G2. Okay, so this is the formula and this is the values. Similarly, Ig2y, which is the moment of inertia with respect to this axis, which is again equal to dB cube divided by 12. Substitute the values, you will get the answer as something like this. The next one is you have to find the centroid. use the summation rule. The formula is x1 a1 plus x2 a2 divided by a1 plus a2. Substitute all the values and you will get the answer as 12.14 meter for x bar. For y bar again is the same summation formula, y1 a1 plus y2 a2 and divided by a1 plus a2. Substitute the values, you will get the answer as 37.14 meter. Now next one is you have to find the moment of inertia with respect to this centroidal x-axis and centroidal y-axis. The moment of inertia about centroidal axis. The first one, moment of inertia with respect to centroidal x-axis, which is equal to moment of inertia for the first section, first rectangle, plus moment of inertia for the second rectangle. So you have to find separately, then you have to add. Now let us go to the angle section again. So far we have calculated the moment of inertia with respect to this axis. Okay, I g1 x, and they have asked you to find moment of inertia with respect to this centroidal axis, which is nothing but I g x. Now since these two are parallel axis, I can go for parallel axis theorem, and now I am going for parallel axis theorem, I g x. Okay, and this the moment of inertia with respect to this axis, which is equal to I g1 x, the moment of inertia with respect to this axis, plus a1, area of this rectangle, then distance, I'm sorry, this one is d, distance square. Distance means the distance between this axis and this axis, that means this distance, this is d. Now d can be taken as, you see here, now this is the distance, y1 is the distance between g1 and x axis. So y1 minus, you see here, y bar is the distance between this centroidal axis and this base axis, so y bar. Okay, this can also be, this is the difference between these two, will give the answer for D. This can also be written as R y bar minus y1. Okay, you can write in this way also, because here you are going to square the number. Okay, so if it is minus or plus, that doesn't matter. So either you can write in this way or in this way, both are correct. Okay, so this is what we are going to do now. Now this is the moment of inertia for the first rectangle, this is the moment of inertia for the second rectangle. Okay, so this is for this moment of inertia of the first centroidal axis, this one Ig1, here it is. Okay, then plus a1, okay, the same formula a1, then distance. So here we have taken already, you can take in this way or in this way, because we are going to squared, so it is nothing wrong in taking anyway. Okay, so this is what here it is taken. Okay, so y bar minus y1 the whole square, plus for the second rectangle Ig2x plus a2. Okay, here also y bar minus, here it should be y2. Okay, the whole square, and substitute the values. Okay, substitute all the values we have already found, and you will get the answer as like this. Okay, make sure that the units are in meter to the power 4. Okay, so this is what the moment of inertia with respect to centroidal x-axis. In the similar manner, you can find the values for centroidal y-axis also. Here is the formula, I1y plus I2y. Now this is the moment of inertia for the first rectangle, this is the moment of inertia for the second rectangle. Now I am going to use parallel axis theorem, already we discussed why we are going for this one. Now this is the moment of inertia for the first rectangle, Ig1y, okay, with respect to y axis, plus a1, here x bar minus x1 the whole square, plus ig2y plus a2 x bar minus x to the whole square. Substitute the values, you will get the answer as something like this. Next one is the moment of inertia about the base axis. Okay, so again go to the same diagram again. I know the moment of inertia with respect to this centroidal axis igx. So this is the value for it. So now I have to find the moment of inertia with respect to this base axis. So this base axis. Now you see here these two axes are separated by y bar. Moreover, this axis is parallel to this one. So I can use parallel axis theorem. And the moment of inertia with respect to this one is I O x. Okay. Now I O x equal to I g x, the moment of inertia about this axis, plus area. I am going to use capital A because I am going to take both these areas. Okay, into distance square. Okay, where A equal to A1 plus A2 and D is equal to distance between these two axes, which is nothing but y bar. Y bar we already know it is equal to 37.14. So here the answer is 37.14. So this is what here I have written using parallel axis theorem. IOX moment of inertia with respect to base axis equal to IGX A into y bar square. A equal to A1 plus A2. Y bar is nothing but 37.14. So substitute all the values and you get the answer as like this. Similar manner we can find the area moment of inertia with respect to base y axis. Again the same formula IGY plus A, here it is x bar to the square. This formula is arrived similar to this one. Okay, substitute the values, you will get the answer as something like this. So that's all about the area moment of inertia with respect to centroidal and base axis. Please go through this video one more time until you get clear understanding. In some book, some authors may use tabular column approach. It is nothing wrong in having tabular column approach also, because both the ways the concepts are similar. So please go through it and understand the concept. Thank you. We will meet in the next video where we are going to solve the second problem in area moment of inertia. Thank you.